All right, so in lesson 7, we are looking at the chain rule. Dun dun dun. The chain rule is awesome. The chain rule is going to be very different than everything that we've done so far. What we're literally doing with the chain rule is we're dealing with a function inside another function. So what that means is I'm not just adding, subtracting, multiplying, or dividing. I've literally got, let's say, h of x inside the function of g. And so obviously taking the derivative of that is going to be a little bit different than everything that we've done so far. I'm going to basically say to you guys, just remember, work from the outside in. That's what we want to do. We want to look at the outside function and then worry about the inside function. So obviously the outside function here is g. So we're going to take the derivative of g and we're going to forget about the inside for the first little bit. And then we're going to multiply that by the derivative of the inside, which is basically h prime of x. Okay, so again, we want to find the derivative of the outside and then multiply it by the derivative of the inside. Now that might not make any sense just yet, but let's look at some examples. Number 1, you can see that I've got an exponent, and not just an exponent, I've got a function to the power of an exponent. So I can't just use the basic old, power rule or anything like that. It's not going to work. I have to use variation. So remember, what we want to do is look from the outside in. So the outside is obviously dealing with that 9, right? Well, we all by now know how to find the basic derivative. We know that that's going to be 9. And what I want you to do is just forget about this guy for a minute. And we know that that's going to be to the power of 8, because remember, we subtract 1. So again, we're working from the outside in. Now, obviously, I can't just scribble that out and forget about it. I have to remember to leave it alone. We're not going to write anything. We're not going to change anything. But what we are going to do now is multiply by the derivative of the inside. So outside in. So the derivative of the inside is going to be 15x squared minus 1. So you guys can see we deal with the outside in literally, and then we take the derivative of the inside and multiply it together. Now we're lucky because in this one, we're pretty much done. There's no simplifying that can be done. Let's take a look at the next one. I'm just going to write it here so I don't run out of room. X squared minus 2x. So remember, right away, we don't want to deal with any of these radicals. Let's get rid of them. X squared minus 2x to the power of a half. And remember, outside in. So you tell me, what is the, well, you can't, but think in your heads, what is the outside? It's a half, right? So we're going to bring that half down. And we're left with x squared minus 2x. And then we're minusing 1 from that exponent. So remember, that's going to give us negative a half. So remember, we didn't touch that inside function. We left it right where it is. And now we're going to multiply by the inside. So the inside derivative, I should be specific, x squared is going to become 2x minus 2. Now this is all good. We're pretty much done. But again, I always mention this might not match the answers in your answer key. So you want to just be very careful with manipulating. Obviously, I've got a negative exponent. I've got a 1/2. So we've got a fraction happening here. So I've got a 2x minus 2 on the top. I've got a 2 on the bottom. And then remember, this is going to become a positive a half. So I could even change that to the root of x squared minus 2x. Okay? And then even what you could do is divide everything by 2, right? So our final answer there could even be x minus 1 over the square root of x squared minus 2x. So chain rule craziness. So hopefully that's okay so far. Those ones, I hate to admit, are a little bit more of the basic ones. So now we're going to get into ones that are a little bit trickier. And I don't mean trickier in the sense that they're harder, but what I do mean is that you're going to have to start combining the rules that we've already learned, like the quotient rule, like the product rule, and incorporate that with the chain rule as well. So what I'm talking about is this example C here. Notice how I've got one function and I'm multiplying it by another function. So everybody would be thinking, oh, okay, well, that's my u and my v. Let's use the product rule. And you would be absolutely right. That is definitely the product rule. However, look at v. V in order to find the derivative of that, we need the chain rule. So not only do we need the chain rule, we need the power rule as well. Chain and power rules. It's exciting. All right, so let's take a look at what our formula is. And remember, uv prime plus vu prime, that is on your formula sheet, as is your chain rule. So let's start going nice and slow. U, we're not changing, so that's just going to be x cubed. Now the derivative of v is not just a no-brainer. We have to think about this one. This is the chain rule. So think about what we just did, guys. Outside in, outside in, outside in. So the 2 needs to come down. So forget about this for right now. So the 2 needs to come down. I'm leaving the inside exactly how it is, and I'm subtracting 1 from that, which is obviously just going to be 1. Now what a common mistake is students do that, and then they're like, sweet, we're done, let's move on. They forget that you also need to multiply by the derivative of the inside. And remember that that is, oops, not 3x, just 3. So again, the derivative of 3x minus 1 is 3. Now we're done. That's the whole derivative of v. Now let's carry on with our product rule. Plus v, which is, again, 3x minus 1 squared, times the derivative of u, I crossed it out here, let's take another look, x cubed. So that's going to be 3x squared. So take a look at that, go nice and slow, make sure that that all makes sense to you guys. And now what we can do is go ahead and simplify. So let's take a look at the first one. I've got 2 times 3 is 6, x cubed times 3x minus 1, plus, I'm just going to rearrange this so it looks a little bit nicer, 3x minus 1 squared. Now, as I'm talking, hopefully you guys are thinking, okay, well, what's going to be the final answer? Hurry up. Here we go. Well, this is good, what we have so far, but I want you guys to take a look and see if we can manipulate this so that it looks even nicer. Think about factoring. Basically, guys, I've got 2 terms, right? First one and a second one there. What's common to both of them? Well, definitely a 3. Definitely an x squared, and definitely a 3x minus 1. So what we can do here is factor everything out. Then what we're going to be left with is 6 divided by 3 is 2, x cubed divided by x squared is x, and 3x minus 1 divided by 3x minus 1 is going to cancel. Plus 3 divided by 3 is gone. X squared divided by x squared is gone. 3x minus 1 squared divided by 3x minus 1 is just going to be the leftover 3x minus 1. So we are factoring using a GCF here. All right, now let's simplify a little bit further. So I've got 3x squared times 3x minus 1 times, and we don't really need these brackets because it's just adding, 5x minus 1. And that can be our final answer. One version. Okay? So lots of work there, mainly in the last little bit. But the most important thing is you need to understand this guy right here. That's the most important, because anything else is just simplifying. All right, so let's try the last one here, the next one. Okay. So I've got inside here, I want you guys to take a look. I'm just going to give you a second. I want you to think about which rules we need here. So in the first one, we needed the chain and the power rules. Which ones do you see here? Hopefully you're seeing the chain rule, right? Because I've got a function to a power, so definitely the chain rule. And what else? The quotient rule. Inside is a quotient. X squared, we're using a division there. Okay, so we're going to have to use that combination. All right, so let's figure out what does the quotient rule look like. I'm going to move this over here because otherwise I'll run out of room. So remember, that's our VU prime minus UV prime over V squared. This is my U, and this is my V. So let's take a look at V first. X plus 2. And now I need to take the, sorry, I lied. Oh my goodness, I forgot my own rules here. I'm doing the derivative of the inside. What was my rule that I said before? outside in. Oh, Mrs. Martin. All right, so 10. We need to deal with this guy first. Bring that 10 down, remember? So 10 times the whole thing, x squared plus 1 over x plus 2. And that's going to be to the power of 9. My goodness. Outside in, don't forget, like I just did. Now, remember with the chain rule, we need to multiply by the derivative of the inside. This is what I was getting all excited about. The derivative of the inside is v, which is x plus 2, times my derivative of u, so that's going to be 2x. Now we're going to minus, and remember I keep reminding you guys with that minus, just be careful, x squared plus 1 times the derivative of my denominator, which is nice, it's just 1, all divided by x plus 2 squared. And that's the derivative of the inside, because remember, outside in, outside in. I should say it more, and then maybe I'll remember it too. All right. Now let's keep going. The simplifying of this looks ridiculous. Let's take a look at the first one and leave it. X squared plus 1 over x plus 2 to the power of 9. That's kind of messy. Let's leave that. Next one, we can simplify what's in the brackets here, right? So I've got 2x squared plus 4x, and then I've got minus x squared minus 1, all divided by x plus 2 squared. And we don't want to expand our denominator unless we have to, because we're lazy. Let's keep going. 10 times x squared plus 1 over x plus 2 to the power of 9 times, I've got 2x squared minus x squared is just x squared plus 4x minus 1 over x plus 2 squared. Now you might get all excited and think, ooh, that numerator, we can probably factor that. You can't. Okay, x squared plus 4x minus 1, unfortunately you cannot factor it. So the favorite part that we have of simplifying and, you know, crossing things out isn't going to happen at that stage. But good news is we can still combine some like terms. We can still simplify this because, let's be honest, this looks pretty messy. Now if I really separate everything, basically I've got x squared plus 1 to the power of 9 divided by x plus 2 to the power of 9, right? And then I've got that being multiplied by x squared plus 4x minus 1 divided by x plus 2 squared. So now what we can do is look at our denominator and say, okay, we're multiplying our denominators together, obviously, so we can combine those guys into nice fraction. So let's make this one big fraction, one big happy family. 10 times x squared plus 1 to the power of 9 times x squared plus 4x minus 1 over x plus 2 to the power of 11, because 9 plus 2 is 11. And that would be our final answer. So what did we learn from that question? Don't make the same mistake I did. We learned outside in. So looking at that question, the outside function has to be dealt with first. So don't make that same mistake. All right. Next one. We're going to do this last example, and then that's it for this lesson. This one looks crazy. This is like a function inside a function inside a function. So we need to figure out, let's, identify what do we have to use here? Well, definitely we need to use the chain rule. And hopefully you might also see the product rule as well, because we are multiplying these guys together. So a couple steps here. Let's first of all get rid of these radicals. So I've got f of x is equal to 2x, x plus 3, that guy's to the power of a half, and that guy's to the power of a half. Now, what did we learn again in that next question? Well, we've got kind of some different functions here. We definitely need to take the derivative of the outside and then work in. Okay, so let's deal, what should we be working with first? What's on the very outside? This guy right here. Okay, so start in a different color just to change things up. So I've got a half, and I'm going to leave everything the way it is. 2x, x plus 3 to the power of a half. And then we're going to minus 1, so that leaves us with a half. So the first chain rule is good. We've dealt with that outside thing. We're kind of sorted when it comes to that. Now forget about that and look at the inside. Well, I've got 2x, and then I've got this. So when you guys are doing this, again, you always want to say, okay, well, what's on the outside? Well, there's really nothing now that's on the outside. This is now the product rule, right? Because I'm taking my one function and I'm timesing it by my other function. So now is where we're going to dip into the product rule. So I've got my uv prime plus vu prime. So let's go ahead and do that. Now remember, this is part of the chain rule that we used originally, so I need to multiply by this answer. So my u is 2x. My v is the chain rule. Look at, I've got a half up here. So this is the pain in the butt where draw a break bracket, go outside, leave the inside exactly how it is, minus 1 times the derivative of the inside, which is x plus 3, which is just going to end up as 1. If this is going too fast, remember you can always rewind, you can always double check, you can always go through this again, right? All right. So the next one is going to be plus, because now we've done our u, which is 2x, times v, so the derivative of this guy, which we said was a half, x plus 3 to the power of negative a half times 1, plus v, which is x plus 3, sorry, I'm totally running out of room, times my derivative of the u, which is just 2. Look at all those brackets. All right, let's simplify. So this is obviously, one of the most important parts that we just did there, is actually taking the proper derivative of it. And now don't lose it. You don't want to lose marks after you've done all that hard work. So let's be careful here. So I've got half times 2x, and all of this is to the power of negative a half, so I can't really break anything up in there, unfortunately. But in here, we can start to simplify. So I'm going to say times, and notice how I've got like a times by 1, that's gone. Like I'm just going to deal with this first function here, or first little term. So I've got times by 1 is gone. Look at, I've got 2 times a half. Well, that's just 1, so that's good. So it's actually just x times x plus 3 to the power of negative a half. So that's looking a little bit nicer. Then I've got plus, and I'm just going to bring that 2 forward in this term here. So I've got 2 times x plus 3 to the power of a half. Now it's still looking a little bit messy and crazy, so let's figure out what can go on the top and what can go on the bottom. So, okay. So basically here, guys, I've got something that can go on the bottom, and everything is being multiplied. So we're going to end up with this guy here is just to the power of 1, right? Like that whole function is being multiplied. So we kind of have to keep it all together. I'm going to take x plus 3, power of negative a half. I can't really break that up. X plus 3 to the power of a half. And all of that now can be divided by this guy, because this whole thing is pretty much to the power of a negative, right? That 2 can go on the bottom, and this whole thing, again, can go on the bottom and become a positive. Okay. So what can we do again? We can just continue on and maybe get in some of our radicals here. So I've got my prime of x. We've got something that we can factor out of the top here. We can do our radicals. So there's lots of things. Sorry, I'm talking about a million things at once. Let's take a look just at our numerator, first of all. What can I factor out of the numerator? Now, this actually comes back from Learning Guide 1, where we said if you have a fraction exponent, remember, look for the smallest exponent and factor that out. So in this case, I can factor out an x plus 3 to the power of negative a half. And we'll be left with, and remember, we're only talking about the numerator right now. I'm going to be left with x, because this guy is going to cancel, plus 2. And now remember, when I'm dividing out an exponent, remember it's like we're subtracting. So basically I'm doing like minus negative a half here to get to reduce that exponent. So a half plus a half is 1. So this is just going to be x plus 3. So I can draw my bracket there. And in the denominator, like I was saying before, I'm saying like 5 million things though, we can bring in our radicals. So a half, I'm going to put the square root there, 2x, square root x plus 3, just to get some of the fractions out of here, because I know they can get a little bit annoying. All right, so far, everybody? All right, so we're going to continue on down. So I've got my derivative. Now, obviously, I've got a negative exponent here. So that I can bring down. So on the top, I've basically got just x plus 2x plus 6, right? So this is just going to become 2x plus 6. So x plus 2x is going to be 3x plus 6 on the top. And on the bottom, I have that 2. I've got this guy here, which is now going to become x plus 3 to the power of positive a half, which I'm going to be lazy so that I don't have to write out the whole thing again. This would become the square root, right, of x plus 3. And then that would be multiplied by what was already down there. So that's the 2x root x plus 3. So that is a crazy question. And I remember when I teach this in class, students always look at me like, what just happened? That is one of the hardest ones that you guys are going to see, because you're using the chain rule, the product rule, and then the chain rule again. So it's kind of nutsos. And you've got lots of fractions in there because of those radicals, which makes it a little bit tricky. But again, remember that this is the first time for some of you that may be hearing this. And so I want you to, remember that this is a tough one. You want to practice the easy stuff first and make your way up to this kind of one. Speaking of practice, where is it? Oh, sorry, it's not on this one. I don't know why. But what you all should be doing now is looking at page 102. And that's number 1, just the left column, 2, 3, 6A, C, E, K, 7, 9, 11, C, and D. Please trust me when I say practice this.